Good morning, or good evening, or afternoon, depending on what time you're watching this. All right, so we are going to write the composition of two functions today. We're going to evaluate the composition of two functions as well. So far you guys have learned how to do this graphically and with a table, and now we're going to learn how to compose functions algebraically, so by hand. So it says a composition of functions forms a new function by substituting the output of the inner function into the outer function. And so I'll explain what that means in a little bit. Actually, I could explain it right now. The function f of g of x is a composition of f and g, where g is the inner function and f is the outer function. So what I tell my students is always work from the inside out. So you would focus on g of x first and then work your way out of that bubble. So like when you throw a rock into a lake and you know how it ripples, the ripple effect, start on that innermost ripple where the rock went through in the water and then work your way out from there. So think of it that way. So the tables show information about Jim's mowing service. Use the tables to evaluate each expression. Then tell what the expression represents. Okay, so first of all, T of 4. All right, T of 4 means that we are dealing with the T of A function, so time to mow, and T of 4. So if the X value is a 4, these are the X's and these are the Y's pretty much, then our output is a 16. So what does that mean? When we plug in the number of acres, when there's 4 acres to be mowed, it's going to take 16 hours. So we can say takes 16 hours to mow. How many acres was that? 4 acres. All right. Next one, C of 4. We're going to be using the C of T function. Okay. So cost to mow. So when the time is in hours, so when there's 4 hours, it's going to cost $110. So we can say it means this costs $110 to mow for 4 hours. C of T of 1. Okay, so start on the inside. Always work inside out. So what does T of 1 represent? T of 1, so the time to mow function, means that it's going to take 4 hours to mow 1 acre. So now I know that the output is 4, so now this becomes C of 4. Well, C of 4 is 110. So C of T of 1 equals 110. So what does this mean? They gave us a lot of information. Means it costs $110 to mow. How many acres was that? Well, it was T of 1, so that means it was 1 acre. To mow 1 acre. For how long? Well, it was C of 4, so that would be 4 hours. Okay. Letter D. C of T of 4. Okay, so start on the inside, T of 4, so the time to mow function. T of 4, so that means they have 4 acres. It's going to take 16 hours to mow those 4 acres. Okay, so I know that T of 4 is 16, because that's the output. Now I have to figure out what is C of 16. Well, cost to mow, C of 16 is $350. Okay, so what does this mean? it means that it's going to cost $350 to mow. How many acres was that? It was 4 acres. And how long? 16 hours. All right. I like my table. It turns. It makes it easy for me. I don't have to keep moving the paper. All right. So number 2, it says reason quantitatively. Use the tables of values below to evaluate each expression. So f of 3. So the input is a 3 on the f of x function. So let's look at the f of x function. We're inputting a 3. The output is a 1. That's it. Isn't that so easy? Letter B, g of 3. So now we're looking at the g function. G, the input is 3. The output is a 2. G of f of 3. So start with f of 3. The input on f is a 3. The output is a 1. So now this becomes g of 1. Well, now go to the g function. What is g of 1? Input is 1. Output is a 4. F of g of 3. So start on the inside. Find g of 3 first. So input is 3 on the g function. Output is 2. So it becomes f of 2. What does f of 2 equal? Well, input on the f of 2, output is a 2. So 1, 2, 4, 2. So easy, right? It's just knowing how to follow the roadmap, pretty much. Turn the page. All right, number 3 says using f and g from item 2, complete each table of values to represent the composite functions of f of g of x and g of f of x. And I want you guys to know over to the right, it talks about this notation. I call it the fog and the goff. Fog, or f of g of x, is the same thing as f of g of x written this way. Okay, it's read as f of g of x. So you're going to see that notation this way and this way. They are equivalent. They mean the same exact thing. So to make it really pop out, let's go ahead and write f of g of x equals f of g of x. They're exactly the same, just a different way to write it. Mathematicians are all about their notation, which is why there's so many different kinds, because people have different preferences. Not everyone agrees on the way to write something, but they're all equivalent. That's all that matters. All right, so we have f of g of x, so that means that we are starting with the inner, which is g of x. So we need to first start with g of x, so g of 1. Let's find g of 1. Actually, I'll just use my notes because I have the table, if I can get it out. G of 1. Well, g of 1 is a 4, so the output is a 4. So now I need to find f of 4, and then I can find that output. Well, f of 4 is 4. So this is a 4. Now let's try a 2. So first, g of 2, and then we take that 2 and plug it into f. So g of 2 is 3. Plug that 3 into the f, and the output is a 1. Now 3. So input g of 3, output is a 2. Plug that into the f, input is 2, output is 2. And a 4. So g of 4 is 1. Plug that into f, f of 1 is 3. So 4, 1, 2, 3. All right, now it's the reverse. G of f of x. Do you think we're going to get the same numbers? g of f of x. So that means we're going to start with f of x this time, and when we get that output, then we plug that into the g function. Okay, so starting with f of 1. F of 1 is 3. Take that 3, plug it into the g function, and the output is a 2. All right, now start with a 2. So f of 2. F of 2 is 2. Take that 2, plug it into the g function, and the output is a 3. Now f of 3. F of 3 is 1. Plug that 1 into the g function, and the output is a 4. F of 4. Input of f of 4, output is a 4. Plug in a 4, output is a 1. So 2, 3, 4, 1. All right. Not so bad, right? Using tables to be able to compose functions is super easy. You just have to know how to follow the roadmap. All right, what does the notation g of h of t represent? What is another way you can write g of h of t? So it's just a composition of functions. So it's a composition. And we can write it as g of h of t, like that. Number 5, explain how f of g of x is different from f times g of x. Well, there is a big difference, and it has to do with the sign in between. This open circle is representing the word of. This dot is representing multiplication. They're very different. So to write this up, we can say f of g of x is a composition. I'm just going to put comp to write it for short. And f times g of x is multiplying. I'm just going to put mult for multiplying the two functions. Okay. Number 6, it says given P of t equals t squared plus 4 and Q of t equals t plus 3, write the equation for P of Q of t. Explain how you determined your answer. So when we explain here, our work is going to do the explaining for this problem. Okay, so we're finding P of Q of t. Okay, P of Q of t. I'm just rewriting it into the format that we like. Okay, so since Q of t is on the inside, I need to start by plugging Q of t into P of t. So we're going to take Q of t, which is t plus 3, and we're going to substitute it in for all the t's in P of t. I only see a t once there. It's that t squared, so we're going to plug it in right there. So this is what we'll get. Instead of t squared, we're plugging in a t plus 3, so it'll be t plus 3 quantity squared. We still have to square it because the t was being squared, plus 4. And now we need to multiply this out so that t plus 3 quantity squared is basically t plus 3 times itself twice with a plus 4 at the end. We are going to need to FOIL this out. So let's see, we'll get t times t is t squared. T times 3 is a 3t. 3 times t is a 3t. 3 times 3 is 9. And then don't forget the plus 4 at the end. And then let's combine like terms, and we'll get t squared. 3t and 3t is a 6t. 9 plus 4 is 13. So P of Q of t equals t squared plus 6t plus 13. For items 7 through 11, use these 3 functions. So now we're really getting into the algebra portion of this lesson, okay? Now that you know how it works on the graph and on the table, Now this is how it works by hand algebraically. So we have f of x, g of x, and h of x here. And it says to evaluate each expression, g of f of 2. So we first need to work on the inside. So we need to find f of 2 first. I'm going to zoom in a little bit so you guys can see that a little bit better. Okay. All right, so f of 2. That means I'm going to take the f function, plug in a 2 for x, and I'm going to have 2 squared. Well, 2 squared is 4. So f of 2 equals 4. Okay, so now I can replace f of 2 with 4, and now it's g of 4. Well, what is g of 4 now? Well, you have to take the g function now and plug in a 4 for x. So that would be 2 times 4 minus 1. So it's 8 minus 1, which is 7. So the answer is 7. Letter B, f of g of 2. It's a little bit different because it starts a different order. Order does matter with these. So start on the inside, g of 2. So we need to find what that is. So we got to plug in a 2 for x in the g of x function. G of x is 2x minus 1, so that would be 2 times 2 minus 1. 2 times 2 is 4. 4 minus 1, I don't know why I put parentheses there. 4 minus 1 is 3. Okay, so now I can replace g of 2 with a 3, so this becomes f of 3. And now I just have to find what f of 3 equals. Well, I got to use the function f of x equals x squared and plug in a 3 for x, so that would be 3 squared, and 3 squared is 9. All right, number 8, it says to write each composite function in terms of x. So now we're not plugging in numbers, but we are plugging in functions. So we're still going to start on the inside and work our way out. We have to plug in f of x into the g of x function. So I'm going to take f of x, it's x squared, and I'm going to substitute it in for the x in the g of x function. All right, let's do it. So we're going to have y equals 2, and then I'm substituting the x squared in for x. So use parentheses whenever you substitute, minus 1. So that would be, what, 2x, just 2x squared minus 1? And that would be g of f of x. All right, what about f of g of x? That's the next one. So for this one, we're starting with g of x, and we're plugging g of x into f of x. So this time, g of x is 2x minus 1, and we're going to substitute that in for the x in f of x. Okay, so instead of x, I'm going to write 2x minus 1 and then squared. So I'm going to come back down here. So y equals 2x minus 1 quantity squared. And you can't leave it like that. We got to multiply it out. So remember, 2x minus 1 quantity squared means we have 2x minus 1 times itself twice. And we need to FOIL that out. So I'm going to multiply that out where you can see it though. So 2x times 2x is a 4x squared. 2x times negative 1 is a negative 2x. Negative 1 times 2x is a negative 2x. Negative 1 times negative 1 is a positive 1. Combine like terms, and we will get that this equals 4x squared minus 4x plus 1. And that is what f of g of x equals. All right, number 9. I'm going to zoom out a little bit now. Whoops. My video stopped recording on me, which is really annoying. But we were at number 9, and I kept going because I didn't know that my phone stopped. All right, so when we verify these and we use our functions that we just wrote, we try g of f of 2. We plug in a 2 for the x there, and the 2x squared minus 1, we get 7, which is the 7 that we got up here. We do the same thing for f of g of x, plug in a 2 into our function that we wrote down here for number 8, and we get 9, just like we did in number 7, part B. So they are the same. So when we plug a function into a function, it's the same thing as when we plug a number into a function and then take that and plug it into another function. It does the same things, okay? So they were verified and they worked. Number 10, I'm just going to walk you guys through it since I already did it. I'm not going to do it again. Evaluate h of g of 3. So we first need to find g of 3. So we have to plug in a 3 for x in the g function. So 2 times 3 minus 1, which is 6 minus 1, which is 5. And then now g of 3 becomes 5. We get h of 5 equals 4 times 5 minus 3, which is 17. Okay, and then they want you to write the composition of h of g of x in terms of x. So that means that we're taking the g function and plugging it into the h function. So the g function is 2x minus 1. The h function is 4x minus 3. So we plug in the 2x minus 1 in for x in the h function. Distribute, combine like terms, and you should get 8x minus 7. And then evaluate g of 2. That means you first need to find g of 2. Ends up being 3. Then take that and find g of 3. That ends up being 5. And then you do the same thing. Plug the g of x function into the g of x function, and you should get 4x minus 3. Okay? And then that was it. All right, your homework, I believe, is on this page, but I will verify that. You'll see it posted. Have a good day.